Did you understand this, guys? All right. So the next part is what were the when he is bombarding, he used an alpha ray emitting source and bombarded gold foil. So what happened here? What were the observations that were found?
Some of the particles made through, but some bounced back, and they got detected by the uh, detectors or the zinc and sulfur wall.
Okay. So would you want to rephrase that, Shreya?
A majority of the alpha particles they pass through the gold foil without
Correct.
showing any deflection.
So the first thing is that majority went through undeflected. Some of them illa, majority 99.9% went through as if the foil itself is not there. Majority of alpha particles passed through, okay, as if the foil was not present. Tanush, are you getting this?
Yes, sir.
That means if you had a detector here, this detector was registering, okay? All the particles, 99.9% were getting registered by the detector, which was just behind the gold foil. Means no deflection, nothing. Okay. Then comes few of them suffered small deflection. Okay. So 99.9 went through. Few of them means you can say 1 in 10,000, 1 in 1 lakh. They suffered small deflection. Means they were detected by a detector here or maybe here. Okay. Which whatever detectors it, because we know the screen was kept like this, isn't it? So it came close to the atom, some atom, and then it got deflected. And the third point is very few of them bounced back. So these are the three things you have to tell. Majority went through as if the foil was not there. Few of them suffered small deflection. Very few of them bounced back. These were the observations. And through this, he gave his inferences. Okay. And I asked you to note it one to one. So majority of them went through without getting deflected. Means inference number one, atom is largely empty. That is the inference. Arey, sab kuch aise seedha chala gaya. Okay, it didn't bounce back, nothing happened. Means that wall is as though the wall is not there. It's as if the atom is largely empty. Okay. Then few of them suffered deflection, isn't it? The nature of the deflection indicated that they encountered a positive portion. Okay. The study of deflected alpha particles suggested they encountered positive particle. Okay, they encountered something which has positive charge inside the atom. Okay, and the third thing is the rebound alpha particles suggested they encountered something very dense. Okay, so when you say some of them rebound is linked to dense particle interaction. Okay, deflected particle refers to the fact that, array, I went there, there is something positive inside the atom, bro. Because of that, as soon as I went, it is repelling me. Okay, so this is the atom, this is the alpha particle. It went close to, it must have gone close to some positively charged portion, because of which it got deflected and got registered in this detector. Similarly, someone else would have come close enough and got deflected like this, got registered. Okay, because it is deflected in this angle like this, it indicates that it was repelled by something inside the atom. Okay, so repelled means it has to be a positive. It encountered a positive particle inside.
So the alpha particle is a positive.
Alpha particle is positive. We said that no, it was He double plus. I'm so surprised you are asking me this question. Do you have notes for the last class?
Yes.
So we saw helium, we removed 2 electrons, all that stuff we did. Now you're asking if alpha particle is positive. Okay, so these were the inferences based on the one-to-one observations that he found. Okay, and based on this, he suggested the atomic model. He suggested the atomic model where he says that atom has largely empty space and it comprises of a nucleus, which is a dense portion. Okay, so he coined the word nucleus. Nucleus, which is positively charged. Atom contains a nucleus which is positively charged. Nucleus spelling is NU, I think. No, nucleus is very dense. Okay, and he knew electrons had to be there. So this fellow said, yeah, the electrons are arranged around the nucleus. The electrons are arranged around the nucleus in circular orbits. Okay, so this is how he thought the atomic structure would be. Are you following this, guys? So while you guys have some sense of what it is, there is a certain exactness to this. Okay, so you have to remember the points and not describe it in a generic way. You have to describe it in a very specific way. Okay, there is a certain exactness to this, which should not be, generalized. The dense one is because of rebound. Nucleus, how did you know is positively charged? Because of the few deflections, and largely empty. Atom is largely empty. This is because bulk of the alpha particles went through, 99.9% of it went through without any deflection whatsoever. Therefore, it had to be empty. So that in effect is the atomic structure which he gave. Are we okay with this? Are you making notes, Tanush?
Yes, sir.
All right. Arin, are you there?
Yes. Sir.
Okay. Shall I move ahead?
So just a second.
I expect you to go through this, children, before you come to the class, no? Thoda, you have to do the revision, no? How can you not even know what we discussed in the last class when we spent at least 1 hour on the Rutherford model? Okay, of course, we did share the slides also where we discussed most of the alpha particles were slightly deflected by small angles. Some of the alpha particles, very few alpha particles appear to rebound. Okay. So this in essence was, his findings, his observations, and therefore he gave these conclusions. There were empty spaces, small nucleus having positive charge. The size of the nucleus is very small and therefore it is very dense. And because of these inferences, he proposed the Rutherford's model of an atom. This guy went off, huh? We'll just give him a minute to join back. Aaron.
They were slightly confused about how there were like so many atoms in a thick sheet of paper, right? So I was like confused about how they were not hitting the atom and bouncing back.
Yes, that in fact how they were not hitting the atom, right? Yeah. So it's a good question. So supposing you are having a wall, think of it like this, right? You're having a wall. This wall is made up of bricks that have holes. Think of it. Supposing you have a brick like this. Okay, but this is not like a solid brick. Think there are holes here.
Yes.
In the bricks. Okay, so these are like special bricks. Imagine they are special bricks which have holes, right? And these holes are like through and through, like tunnels inside. Okay, so these bricks are like that. And then what you do, you are not putting a tennis ball, rather you are taking a mustard. Mustard means, no, you use it in cooking. And that mustard you are shooting against this wall, which has bricks, and the bricks have holes. Are you following this? So what will happen? The chance that the mustard, there is always the chance that the mustard will go through these bricks without bouncing back, no? Because mustard is so small, and the bricks are there. Bricks are having large holes, so the mustard will go through. How many ever layers of bricks you may have, 4 layers, 5 layers, because the size of the mustard is so small when compared to the the holes here, the mustard is expected to go through. Are you following this? So this is the analogy here. So when you say atom, don't think that the atom is like a solid marble and that if you go near it, it will bounce back. It's not like that. Okay, so you should think of the atom like a brick, and this brick has got big holes, and whatever you go shooting at it, the size of that alpha particle is small, so it's kind of going through. Sup karke andar se ja raha hai. Did you get this analogy?
Yes. So like even if they come close to the atom, they'll get refracted due to their positive.
Yeah. So if you want to think of the actual nucleus, the nucleus is like a small dot inside the hole. So if that mustard particle is coming close to that small nucleus, then it will get deflected. Okay, but the mustard has got so many spaces for it to just pass through that empty space, isn't it?
Yes.
Okay, so that is how you should think of it. Not that the atom is like a solid brick, but a brick that is having a large amount of hole. And that hole has a very small speck, and that speck is very dense. So when the mustard is going and hitting that speck, it will come back. When that mustard is going close to the speck, it is getting deflected. But by and large, the mustard is just going zoop, zoop, zoop in so much of empty space that is available to it. Okay, so if I can show the mustard in blue, it's like it can go whenever it is going all these places. It's just going through without any deflection. When it comes close to the nucleus, then it is getting deflected. This is the nucleus here.
Yes.
Did you follow that?
Yes, sir.
Any other questions you have regarding this Rutherford's experiment?
No, sir. I understood.
All clear? All right. So then we study something. We study, was Rutherford right? Okay, are there any drawbacks to this? Okay. Yes, there are a few drawbacks where while he got majority of the things right, there are a few drawbacks. Okay. The first drawback is something to do with physics. Okay. And that you will learn in later grades. Okay. Which states that accelerating charges lose energy. You must just learn this as it is, okay? So what it means is this electron is there, no? What this fellow Rutherford said in his model, there is a positively charged nucleus, and he called those positive charges as protons, okay? And then the electrons are revolving around the nucleus in circular orbits. This is what his model said, okay? So there are two things here. One, electron is a charged particle, okay? And it is going round and round the nucleus. So you would have learned this in your motion. When will objects go round and round? What is that motion called? Round and round.
Centrifugal.
Huh?
Centrifugal.
It's called uniform circular motion, isn't it? Uniform circular motion is when you can take a string and you can have a ball at the end of it, and you can hold it here and you can keep doing round and round. It will do the uniform circular motion. And they will ask you question, is in uniform circular motion, is it constant velocity? What would you answer for that? Is uniform circular motion constant velocity, or is it acceleration?
I think it's no, because at every point
Yes, a different.
turning it is changing direction, so it cannot be uniform acceleration motion. Or
It cannot be uniform velocity, isn't it?
velocity.
It is accelerated. So beautifully put, okay? Because it's going round and round. If it is changing direction, means it is accelerated. And as Aryan pointed out, the thread that connects the ball, okay, to your hand, that thread is, providing the force, centrifugal force, okay? In fact, it's not centrifugal force, it's centripetal force. The pseudo force which acts in the opposite direction, that is called centrifugal. This is called centripetal, towards the center, okay? So this centripetal force is providing the acceleration for the object to go round and round, okay? So uniform circular motion is accelerated motion, okay? Now you come back to these electrons going round and round. If these electrons are going round and round, that means they are accelerating, correct, no? So you have two things. One is you have a charge, electron is a charge. And by virtue of the electron going round and round the nucleus, we know that it is accelerated motion. Are you able to follow this, guys? Okay. And there is that thing in physics which says that, if you are having an accelerating charges, okay, then they are going to lose energy. That there is one statement, there is a fact in physics. Okay, that means as per Rutherford's model, this electron has to lose energy. And when the electron lose energy, what happens? It cannot remain in this place. It will actually spiral towards the nucleus and finally collapse inside the nucleus. This is what should happen, because the electron is losing the energy. It cannot remain in the orbit. It has to spiral towards the nucleus and collapse. Okay, that is what is expected from physics, but that doesn't happen. Okay, so Rutherford's theory could not explain why this is not happening. How is the atom stable? Okay, as per the physics, the electron should collapse and the atom should not exist. Okay, but it is not happening. The electrons are revolving around the or going around the nucleus. Rutherford's model could not explain how. Okay, so I will write the drawback. Accelerating charges lose energy as per physics. Okay, and therefore the electrons that are revolving around the nucleus should spiral inwards and collapse in the nucleus. Are you following this? It's like the earth, which is revolving around the sun. It is losing energy. What will happen? The earth will go spiral inwards and crash inside the sun. Okay. But this does not happen. Okay. So Rutherford could not explain it. So that's one major drawback. Are you following this, guys? So, Shreya, can you please read the text in the slide, please?
Facts of electron model of the atom. Any charged particle in a circular orbit will undergo acceleration, and during acceleration, the charged particles would radiate energy. So the revolving electrons would lose energy and fall into the nucleus, and the atom would be unstable. We know that atoms are stable.
Okay. We know that the atoms are stable. This is what is expected, that if the atoms lose energy, they would have to spiral towards the nucleus, positively charged nucleus, and collapse. This is the expected behavior. Okay, but it doesn't happen, and Rutherford could not explain that. There is one more defect, though, okay, which is not there in your textbooks, but you may, you may want to note it down. The mass of the atom, okay, could not be successfully explained. Because the neutrons are not yet discovered. No, he didn't know what neutrons were and how the mass of the atom is made up of protons and neutrons together. Okay, because till then the discovery of neutron has not happened. So he knows that protons are there, electrons are there. And when you're trying to find out we know that protons equal to electrons, isn't it? So if there are 18 protons, there will be 18 electrons, right? But when you compute the mass of the atom, we see that, yeah, it is still more than number of protons and electrons. Somewhere you're not accounting for the mass, obviously, because neutrons are still not discovered, isn't it? So that was the second problem. Okay, he could not explain the mass of the atom. Are you following this, guys? Later on, this fellow Chadwick in 1932, there was a scientist called Chadwick who, through experiments, discovered the presence of neutral particles within the nucleus.
So we can't see the one also.
Say again. Oh, I'm so sorry. I'm writing that. So 1932, Chadwick, who through experiments discovered the presence of neutral particles within the nucleus. Okay, he called them as neutrons. Okay, so Rutherford did not discover neutron. It was Chadwick who discovered neutron through some experiments. What experiment he did and all is not required. Okay, because that's not it's like a two-step process. Okay, he bombarded beryllium and then he got out some particles, and then that particle went and ionized some gases, and a lot of calculations happened, and then they discovered neutron. That's the reason it is not ever taught to you. Okay, you just need to know that 1932, Chadwick is the fellow scientist who discovered neutron in the atom. The science to explain that is little difficult for ninth. Did you understand the drawback of Rutherford's model, guys? All right. So now come to Neil Bohr. Okay. So Bohr is the savior for Rutherford's model. Okay. He's a very intelligent guy. He came up with a solution. Okay. What he proposed. Okay. He said that, yeah, yes, I agree. Atom has nucleus. Okay. And nucleus has positively charged particles. Okay. He also said that these electrons are going round and round the nucleus. Okay. This is also true. But what this fellow said, these electrons are going around in this orbit, no? This orbit has fixed energy. Okay, he said that, yeah, this is going in a shell. It has got some fixed energy. Okay. So long as the electron is orbiting in this fixed energy, okay. So I will write it down here. Bohr proposed that electrons revolve around atom in fixed energy shells, and he called them as orbits. Okay, fixed energy orbits or shells. Okay, and he said that as long as the electron was in that shell, in that orbit, you can say in that shell or in that orbit, it neither loses nor gains energy. Are you following this? Okay, so this is where the quantum model of an atom, okay, the beginnings of quantum physics, we keep saying no quantum physics and all. quantum physics means energy levels within atom, all that stuff, right? So you can say that Niels Bohr is the first guy who actually defined these energy levels, right? In fact, he went on to say these energy shells are like n is equal to 1, n is equal to 2, n is equal to 3. All this was given by Bohr only. Okay, so you say that these shells or energy levels can be represented by a number n, okay, whose values could be n is equal to 1, 2, 3, so on. Okay, so you can see this slide which kind of explains what those shells are, right? So you have this positively charged nucleus, he's sticking to that. And then he's telling that, yes, electrons are going around the atom in some orbits. He is also sticking to that. Only thing he's telling is that, yeah, these orbits are there, no? They are all, having a certain fixed energy, okay? And he is calling them as shells, okay? Shells or energy levels, okay? And that you can represent them with a number. N is equal to 1, 2, 3, okay? And then he says that as long as the electron is in that particular shell, this is n is equal to 3 shell, or this shell, n is equal to 1 shell, okay? It neither gains nor loses energy. Energy of that electron is quantized, means now it cannot be changed as long as it is there. Okay. In fact, we have the name of the shells based on the number. Okay. So this n is equal to 1. What shell is that you have learned, guys?
Okay.
N is equal to 1 is what we call the K shell. Okay. N is equal to 2. K, we call it as the L shell. Okay. This has got some fixed energy. Okay. When n is equal to 2 L shell, it is having a fixed energy. But it is higher than n is equal to 1. So this n is equal to 2 wala K shell, L shell is higher energy than K shell. Okay. N is equal to 3 is the M shell, which has got even more higher energy than the L shell. Are you following this? So you can say K shell is the least.
But 2 is the maximum. That can hold 2.
We will come to that little later. First, just understand that what is this N, what is this shell, okay? In fact, this N has been given a name. It is called the principal quantum number. N is called the principal quantum number, whose values can be integer multiples. I mean, is positive integers, 1, 2, 3, 4, etc. It can go up to infinite. N can be n is equal to infinity also is possible. That means it is the electron is no longer associated to the atom. If you are going so far away that the shell is infinite, means you are no longer associated with the atom. The electron is outside the atom.
So then how will, so there's a certain attraction, right? So like the nucleus has a certain attraction and how it holds the electrons.
Correct. But if it is far away,
It will be like really low and it won't be part of the.
correct. So if it is, if it is close to the atom nucleus, yes. Okay, just like Earth is there, no, Sun and Earth, right? The Earth also is held by the gravity of the Sun. Okay, so Earth experiences considerable gravitational force. That's why it doesn't fly away. Okay, and it keeps going round and round the Sun, isn't it? But imagine the Earth is very far away. Okay, the Sun cannot hold the Earth towards it. Okay, it will say, yeah, you're so far away. I cannot pull you towards me. I cannot extend that gravitational pull. My force is going to be very weak, isn't it? So that is what is the infinity shell. If the electron is so far away from the nucleus will say, Baba, tu itna dur hai. How can I, pull you towards me? How can I keep you as mine? Okay, someone gives little energy means that electron will go away. It cannot bind that electron. Are you following this?
Yes.
All right. So, can you explain, Naren, what is the drawback of Rutherford's model and how Niels Bohr fixed it?
Sir, electrons are accelerating charges, so they lose energy. So this Rutherford thought that they would come into the center of the nucleus and they would collapse.
No, Rutherford didn't think that. Rutherford simply said, these electrons are there, they're going round and round around the nucleus, and he left it. Then the scientists are reviewing, no, what is the model given by Rutherford? Acha, he's telling electrons are going round and round the nucleus. Then they bring the law point. Arey bhaiya, but electron is a negative charged particle. Going round and round means accelerating. Accelerating charges will radiate energy. That means they're losing energy. So they should collapse into the nucleus. So the people who are reviewing the proposed model given by Rutherford, they will give these kind of law points, physics related questions. And Rutherford could not explain. He could not say, he could not justify. He didn't know how to explain it. Are you following this? Don't say Rutherford said that it will collapse. Rutherford didn't say that. The people who are reviewing his model using physics, they found out a loophole and they presented it as a drawback. And Rutherford could not explain that. He could not justify it. Okay, Tanush, tell me how Niels Bohr came and he saved the atomic model. What did he propose?
So Niels Bohr proposed that electrons that revolve around the atom are in a fixed orbit or a shell. So as long as the electrons were in that shell orbit, they neither gain nor lose electrons.
Okay, Shreya, what is the most important part Tanush missed?
So
he called.
Shreya?
Sir, n is the principal quantum number, and it depicts the number of shells.
Not that. Okay, he missed the fact that electrons are revolving around it in shells which has fixed energy. You can't use the word shell without emphasizing the fact that shell has got some energy. Okay, some joules, 10 joules, 15 joules, 12.5 joules. Okay, so that shell is a space around the atom. Okay, And as long as the electron is in that shell,
So it
it is-
neither gains or loses
yeah, so
energy.
that shell has got fixed energy. Therefore, electron in that shell will neither gain or lose. Therefore, it does not collapse.
Yes.
Okay, so don't miss the fact that fixed energy shell. Okay, and then the point that Shreya mentioned, Are, how do I know which shell has what energy? Bhaiya, take this, n is equal to 1. I will give them names. Now I will give them some numbers. Okay, n is equal to 1 is first shell, K shell, n is equal to 2,
Yes.
L shell, n is equal to 3, M shell. So he gave the way to name them. In fact, you can actually calculate the energy with some formula which you learn in 12th grade.
The 2n square.
Not 2n square. 2n square is number of electrons. You can calculate the energy associated with each of these fellow. Okay, minus 13.6 z square by n square, and formula is there. Using that, you can calculate the energy of the electron in a particular shell, where z is the atomic number and n is the shell, the number of the shell. Okay, which you will learn in atomic physics. Okay, in grade 12. Very interesting. And not grade 12, in grade 11 you learn in chemistry. Grade 11, not 12. Are you okay with this? So you should be able to, this is a very, very important topic. Okay, in atomic structure only Rutherford and Bohr will come. So you have to remember these points without mincing words. You have to state it. Okay, so with this fixed, then he will say, yeah, how to distribute the electrons? Electrons cannot randomly go, because now you said first floor is second floor, third floor. How will the electrons be distributed? Okay, so now comes the method for distributing electrons. Around the atom. Okay, so which is what Aryan you mentioned. Okay, that 2n square formula, number of electrons in a shell. Okay, so the 2n square is nothing but
To calculate the maximum capacity.
maximum number of electrons in a shell is given by the formula 2n square. Okay, so we use this formula for distributing electrons. Okay, so we say, hydrogen, come man. How many electrons do you have? Hydrogen will say, sir, I have only 1 electron, sir. Oh, 1 electron, huh? You can go into the first shell, bro, because that K shell, no, has n is equal to 1, and its capacity is 2 into n square. 2 into 1 square is 2. Okay, so you go and sit in the first shell. Okay, then helium will come. So this fellow asks, okay, how many electrons you have, helium? He will say, sir, I have 2 electrons. Oh, 2 electrons. My K shell has capacity for 2. So you also put both the electrons in the first shell and sit tight. So helium will have 2 electrons in the first shell. Then lithium will come. When lithium comes, you will ask, yeah, how many electrons you have? I have 3, sir. Oh, 3, yeah, you can't go into first shell, bro. 2 of you go into first shell. The third fellow go into second shell. Okay, because now when you come to n is equal to 2, this second shell will have a capacity how much, guys?
8.
It has maximum 8 people can sleep in that second shell. Okay, so you are 3, so 1 fellow has to sleep in the second shell. So like that you can keep on distributing it. Okay, now next will come boron, carbon, beryllium, right? All those guys, the electrons will keep going here until 2,8. Which is 2,8, guys?
Sir,
So neon,
Until neon. Okay,
calcium.
that's 20. Calcium.
yeah, until
Calcium is
2,8. And then 2,8, after 10, 11 will come. Okay, this is z is equal to 10. Z is
2, 8,
equal to
1.
11. 11. This fellow is sodium, na? Then you will say, Bhaiya, sodium, oh, you have 11, na? Then your second shell is filled, bro. So you have to put your 11th
281.
electron in the third shell. Okay. So that is what is that electronic configuration which we talk about, 281. So the entire electronic configuration which we now know is governed by this formula 2n square. Okay, that is the mantra for distributing the electrons around the atom. Are you with me on this, guys? Can you please make a small note of this? And this is the corresponding text. Okay, and one important thing to take care in electron distribution is always the lowest energy will get filled first, and you can go to the higher energy states only later. Okay, so that's also another rule, thumb rule. Lower energy states get filled first. So even though hydrogen has only one electron, it cannot go into the third shell. Okay, because first shell is there with the lowest energy. So first he has to go into that. So electrons cannot be filled in a shell unless the inner shells are filled. Inner shell means n is equal to 1, n is equal to 2. You have to first fill them. Then only you can put them in n is equal to 3, n is equal to 4, etc. Are you okay with this, guys?
Yes.
Okay. And therefore, if you see, I have put some elements till 20, I guess. Okay. So you have this K shell, L shell, M shell, N shell. Okay. And you see the distribution 27, 28, 281, 282 till 288, which is for argon. Argon is 18 electrons, isn't it?
There's calcium 2882.
Yeah, I mean, I have just prepared till argon. Calcium is 22882. Okay, it's not necessary for you to make a note of this table, but you guys should realize that this entire electronic configuration is coming because of this formula 2n square. And please pay a note to the valency, which we are putting in the end, okay? The last column. So valency represents the number of, okay, it indicates the combining capacity, okay? And if you have
Gain or lose.
yeah, how many electrons the atom can gain or lose, okay? So it is, if it is 1, then the valency is 1. If it is 2, it is inert gas, nothing will be there in the outer shell. If it is 3, once again it is 1. Okay, so till 4, okay, till 4, the number of electrons in the outermost shell is the valency. Okay, but more than 4, it is 8 minus the number of electrons in the outermost shell. For example, for nitrogen, it is 2,5. Okay, so you will say, Acha, you have 5 electrons, huh? So I will do 8 minus 5. 8 minus 5 is 3. So your valency becomes 3. Okay, what we are trying to say is nitrogen is not going to lose away 5 electrons. No way. It will say, boss, you give me 3 and I will become 2,8. Okay, so here beyond 4 electrons in the outer shell, you have to do 8 minus the number of electrons in the outermost shell. So here it is 8 minus 5. Here if you see 6 electrons are there. So it is 8 minus 6 is equal to 2.
So it will be -2, right?
Yeah. So this is 7 electrons are there. So 8 minus 7 is 1. Here 8 electrons are there in the L shell. Therefore, this will be 8 minus 8, which is 0. That means there is no inert gas. Okay. So, in fact, using this electronic configuration, this 2n square formula, you also will be able to compute the valency of an atom. Are you okay with this?
Yes.
And this is just a general representation. Like I was telling, each atom is coming and we are trying to distribute the electrons. Helium has 2, then lithium has 2, 1, and so on and so forth. Okay. So if you see here, argon has 2, 8, 8. All the 18 electrons are filled in the first 3 shells. Any questions about this, guys?
No, sir.
All right. So we also discussed about valency here. Valency is about combining capacity. And one thing is valence electrons. Valence electrons and valency are different. Valence electrons means how many electrons are there in the outermost shell. For example, fluorine. How many electrons are there? What is the how many valence electrons are there in fluorine?
So 7.
7. Okay. How many? So valence is different than valency. Valency is 8 minus 7, 1.
1.
A valence electrons means how many electrons are in the outermost shell? 7. Okay. If it is a small,
So it will be -1.
sorry.
So fluorine's valency.
No. For valency, no, don't put positive or negative.
Okay.
Always valency is a number. It doesn't have a sign associated with that. Okay, this is a common confusion that we have in when we are learning this valency. Valency is not having a positive or a negative sign. Okay. So, for example, sodium is there, no? Don't say valency of sodium is +1. Say the valency of sodium is 1. Okay. Fluorine, for example, okay, 281. Fluorine is 2, 7. Don't say the valency of fluorine is -1. Valency of fluorine is also 1. Are you following this?
Yes.
Okay. But what happens is when the sodium fellow is giving away 1, it becomes an ion. Okay. So you can say that sodium with a valency of 1, when it loses the electron, right, becomes a sodium ion. Okay, so sodium positive ion is a consequence of the valency, but valency by itself is not positive or negative. Okay, for example, 2,7, valency of fluorine is 1. It means it wants to get 1 electron, gain. Here, this is lose. Lose 1, this is gain 1. Okay, so when it gains it, fluorine will become F minus. Okay, but that is not to be confused with valency.
Okay.
Okay, so it is like valency is only going to indicate combining capacity. Okay, and it is not in any way connected with plus or minus. That is a common misconception. So it's good that you asked this question. Okay, so see 1, 2, 3 you can lose. Okay, with 4 no, you can't say it is losing. You use the word sharing. Okay, 1 means you can lose, 2 you can lose, 3 you can lose, but 4 onwards you will share. 5 you will gain, 6 you will gain, 7 you will gain. Are you okay with this?
The 4 is sharing.
Sorry?
If it's 4 means it's sharing.
Yeah, 4 you can't say it is give or gain. 4 you will say share. Okay. So now we have to discuss about certain, we have already seen that when we are talking about molecular formula and all that stuff. Okay. So we talk about two things, atomic number and mass number. Okay. So you all know what is atomic number, right? What is the, how is atomic number represented, guys?
That
Z. Atomic number is represented by the symbol Z. What does atomic number indicate? It indicates number of protons. Shreya, why are you not speaking? Unmute and speak. Okay, answer. What does atomic number indicate? Atomic number indicates the number of protons. Okay. Now, what does so if you say array atomic number of an element Z is equal to 12, okay, how many electrons will that neutral element have? What will you say?
Atomic
Well, what?
mass.
How many electrons will an element with Z is equal to 12 have?
So 12 is well.
It will be 12 only, okay?
Yeah,
But-
proton.
Yeah, but can you say atomic number means number of protons or number of electrons? Can you say that?
No, sir.
Okay, so again, that is another misconception which students will think, because they know that in atoms, number of protons is equal to number of electrons in neutral atoms, right? So they wrongly say atomic number could be number of protons or number of electrons. That is a big wrong answer. Okay, atomic number Z always is equal to number of protons. Okay, do not mention electrons. Okay, when you're talking about atomic number. Tanush, did you understand that?
Yes, sir.
Why should we not talk about electrons? Because after all, protons and electrons are equal, no? So why can't we say atomic number is number of protons or the number of electrons?
So then, negative,
Because we've just now learned, no, the electrons can be lost or gained, isn't it? So chlorine atom is there, it may gain, then electrons are changing, but the atom itself is not changing. It is chlorine only, isn't it? But chlorine has gained something, sodium has lost something. Okay, so electrons is not a good indicator for the element, isn't it? So that's why protons, because protons
So
cannot.
because so
Yeah,
because electrons can be lost or gained and protons are stable, that's it.
not protons are stable. Protons are within the nucleus, so you can't disrupt
They
a proton.
don't
they don't
Yeah.
multiply.
They don't change.
Increase
they
or
don't change.
Okay.
Yeah.
Therefore, the roll number for an atom, the roll number for an element is always protons
Proton.
because it doesn't change. Okay, roll number identifies you. Similarly, number of protons identifies an element. Number of protons is the identifier for an element. This is the first thing. Z. Next we have mass number. What is mass number indicated with?
A.
It is going to be A. Okay. So what is mass number? We know what it is. Tell me. What is A equal to? Z is protons. What is A equal to? Protons plus neutrons. Okay. So mass number A is nothing but protons plus neutrons in the element. Are you following this, guys?
Yes.
Okay, so if supposing I say, Bhaiya, I have an element bro, the number of protons is equal to 12, the number of neutrons is equal to 13. Okay, what will its mass number be?
20.
Huh?
20.
20, yeah.
No, sir.
5.
25.
That 5 you're swallowing, it is going to be 25. Okay, and how will you represent this element? Supposing I say this element is X, okay, you will say X, 12, and 25.
on the top.
Okay, so
Yes.
the fellow Z is there, no? Z will come at the bottom, and this A fellow will come at the top. Okay, it's like this, Z, A. Okay, can you please make a note of this with a small example? An element has 12 protons and 13 neutrons. What is its mass number? Find its mass number. Make that question, give this answer, and then how to represent that element. Okay, representing that element. Okay, if he says an element X, don't say protons is 12. No, so I know it is 282. 282 is magnesium. Don't say Mg. Okay, because he called that element X, you say it is X, even though you know protons 12 means magnesium. Okay, so once you've made a note of that, you can go for a small break and come back in 5 minutes.
Then we can take a break.
Yes, please. And this is for Aditya, okay? So next is, we've discussed mass number, we discussed atomic number. Okay. We'll discuss next about isotope. Okay. So do you know what isotopes are? Isotope. Okay. What are isotopes? Okay. So these are elements which have
They have a variable valence.
No. They are
They're
same
different.
atomic number. Okay. They have the same atomic number. Means they're the same element. For example, carbon.
So, but they have different mass number.
That is it. Okay. So this fellow will be same. This is 6. This is 6. Okay. But this fellow may be 13. This fellow will be 12. Okay. That means they have the same atomic number, but different mass numbers. Okay. So isotopes are elements which are having the same atomic number but different mass numbers. Okay. So what is the difference between this fellow? Mass number is same, means what is different?
So they have different number of neutrons.
Neutrons are different, okay? So for this guy, protons are 6, electrons also are 6, neutrons are 7, okay? But for this fellow, protons are 6, electrons once again are 6, but neutrons are 6 as against 7, okay? So they differ in the neutrons, okay? That means they differ in number of neutrons. Did you understand what isotopes are, guys?
Yes.
So, do you think isotopes are something which is rare or they are frequent?
Rare.
Are rare occurrence or frequent
So
occurrence?
they are rare.
Any other guesses? Okay, you will be surprised that, okay, there are only a few elements, I think around 18 elements that don't have isotopes. That means isotopes are very, very frequent. All elements, almost all elements have isotopes. Okay. Are you following this? So that is again another misconception that, isotopes means only few elements will have. No. Majority of the elements have isotopes. Few of the elements don't have isotopes. Okay. In fact, I have compiled a list of elements which don't have natural isotopes, and they are these guys. I'll just make them bold. Okay. Beryllium, fluorine, sodium, aluminium, phosphorus, scandium, manganese, cobalt, and up till bismuth. They are all random numbers. Okay. But if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So these are the 20 elements that don't have isotopes. And sometimes you can create isotopes in the lab. So these don't have naturally occurring isotopes.
So what are the numbers?
Huh?
So what are the numbers in front of the elements?
What are they?
Numbers in front of the elements.
Arey Baba, you should guess, no? What is this? Mass number is given. Naturally occurring.
Oh,
Okay, that means all others, hydrogen has an isotope. Okay, helium will have an isotope. Carbon has isotopes. Oxygen has isotopes. Chlorine has isotopes. Okay, so you can say 118 minus 20. That means
98.
98 elements have isotopes. Majority of them have it. Okay. So some of the important isotopes that we must know are for hydrogen. Okay. Hydrogen has 3 isotopes. One is called protium, the second one is called deuterium, and the third one is called tritium. Okay, you can make a note of this: 1H1, 1H2, and 1H3. Normally, when we say hydrogen has no neutrons, we are referring to 1H1. Tritium has, how many neutrons has tritium?
2.
2 neutrons, okay? 1 proton and 2 neutrons. Likewise, carbon also has got 2 isotopes, okay? The first isotope is C612 and the second one is C614. Okay, so the C612 is very important because that, yeah, you know, right? Why is C612 important?
Sir, it is the
AMU.
atomic mass. Yeah.
For the definition of atomic mass, you refer to this fellow.
1/12.
1/12 of C612 is taken as 1 AMU, isn't it? That's why this fellow is important. Okay. Likewise, chlorine also has two isotopes. Okay. One fellow is 1735 and the other fellow is 1737. Okay. So you must remember these are some of the important isotopes. In fact, for chlorine, I think you have one more isotope. 36 is also there. I'll just check it up once. Chlorine isotope. If I show you this, will fall off. Okay. Can you see this? How many
are there?
Difficult for me to count, bro. I think I can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Around 30 isotopes are there for chlorine.
The 36 is also there.
Yeah, around 30, 36, 35 isotopes. Chlorine. Okay, but majority of it is 35 and 37. And 36 also. Okay, others may be there, but you know, naturally occurring only these three. In fact, when you say, hey, what is the atomic mass of chlorine? No, you will say 35.5.
Yes.
You know that, no? So then they will say, yeah, how did you get this 35.5? How can neutrons be, you know, in fraction? The answer to that is, they say, Bhaiya, when I have to calculate this atomic mass, right? I have to consider what are the isotopes of chlorine available. Okay. So chlorine will be, you know, 35 fellow is also there. Chlorine 37 is also there. Okay. Then you will say, hey, what is the percentage of this, bro? Is this 70% of it is 35? You know, 20% of it is 37. You tell me what is the percentage of occurrence, right? So that is important. Percentage of occurrence is also there. Are you understanding this? Because when you have isotopes, it is not that both the fellows are existing 50-50. 50% of chlorine isotope 35, 50% of 37. No, they may exist in different percentages. Maybe this fellow is 99% chlorine 35, maybe 1% only 37, right? That is what is called percentage of occurrence, right? Then what we will do is, we will take the percentage of occurrence, we will take the mass number and calculate what is called the weighted average. Are you following this, guys? Are you able to understand what I'm saying?
So what is weighted out?
Wait, that's what I'm saying. So based on how much of 35 exists in the nature, okay, you coin something called percentage of occurrence. 35 in this universe is what percentage is it? Is it 50% of all chlorine is 35? 70% of all chlorine is 35. So you have to estimate how much of, if 100% of chlorine is 35, then the mass number of chlorine we will keep as 35 only. Okay. But if 90% of chlorine is 35 and 10% of chlorine is 37, then we have to calculate. For chlorine, let us calculate the mass number in this way. You will say 35 into 0.9 plus 37 into 0.1. This is what is called the weighted average. Are you following this? So here, this is percentage of occurrence. This is the mass number. 10% percentage of occurrence. This is the mass number. So if you calculate this, this will be the mass number that we will take. Are you following this? Here I have given 90 and 10 just as some value. Okay. They have to tell you what is the percentage of occurrence. Okay. A%, B%, they will tell you. So take the mass number multiplied by the percentage of occurrence plus take the second isotope, its mass number multiplied by its percentage of occurrence, add it up. That will be the mass number for that particular element in the periodic table. Are you following this? Okay. So let's do that for chlorine. Okay. I will tell you its percentage of occurrence. Then we'll calculate.
Hey, it's only for chlorine.
Huh?
So is it only for chlorine?
No, we can calculate like this for all elements. If they tell us what isotope exists in how much percentage. Are you following this?
Yes.
So chlorine 35 is 75%. Make a note. Chlorine 35 is 75%. Okay. Chlorine 37 is 25%. So calculate the weighted average of this now.
Can you repeat?
Yeah. What are you guys doing? Chlorine 35 occurs 75% of the time. This is the occurrence. And chlorine 37 occurs 25% of time. Okay. Therefore, what should be the atomic mass of chlorine?
I want to be 35.5.
Not like, how do you calculate it, bro? Don't remember it and ratify and tell. That's why I've given the formula here, no?
That will be 35 into 75 by 100 plus.
Very
30.
good. Correct. 35 into 75 by 100 means 0.75, no? 35 into 0.75 plus 37 into 0.25. Calculate that and tell me how much is that?
So it will be 26.25 plus 9.25.
26.25 plus
9.25.
9.25. Okay. So if you see this, it will become 35.50. So this what you did is what is called finding the weighted average. Weighted means this 35 wala variety, what percentage is it in occurrence? Okay, like boys are 60%, girls are 40%. Like that, this 35 variety, how much percentage is it occurring in the nature? 75% of the time. So its mass is giving more weightage. The 37 variety is only 25%. So when you do this, it is called we are taking the weighted average of both the isotopes and we are arriving at the number 35.5. That means all the other varieties which we saw there, they are very, very small. So we are ignoring them. This is the majority, 35 and 37. Okay, so if they given in the we do one more example. Okay, there is an element X. Okay, which has mass number 25, 27, and 28. And the percentage of occurrence is 10%, 25%, and the rest of it is this 28. Find its mass number.
The 28 and how much percentage?
I'll not tell. अरे ये 10 है, ये 25 है, तो ये कितना होगा दोस्त?
Oh, the remaining.
You add what?
Remaining. How much are you getting? You punch it out in calculator, okay? Anyone done it?
So I got
There will be 2.5 plus
2.5 plus 6.7.
0.75
Do
plus
it and tell me, bro.
So 27.45.
27.45.
45.
You have to put U, okay? Whenever you are discussing about mass number, don't forget to put U.
Yes.
Okay, so that would be, as we discussed, 25 into 10% means 0.1 plus 27 into 0.25 plus 28 into 0.65. Whatever it is will be the answer. Okay, so this is how weighted averages are calculated. So the last part of the story is discussing what are called isobars. Okay, isotopes are very important and you should know how to do all this. Okay, tell me, what could isobars be?
Different atomic number and same mass.
Say again.
Different atomic number but same mass.
Perfect. Okay, so here these fellows were same, bottom fellows. Okay, and the top fellows were different, isn't it? Here the top fellows are same.
Oh yes, sir. Argon and
Yeah,
calcium.
here here it
Argon
is
and calcium have 40.
correct. This is 40, this is 40. Okay, whereas this will be different. Okay, this may be 20, this may be 22. Okay, so make a note of this. Isobars are elements having the same mass number. Mass number is same, but atomic number is different. Okay, so these will not, I have made a small mistake here. Okay, I have put both as X. Okay, can I do that? I can't, because if the 20, this is 22, no? How can be the same element?
Yes,
Isn't it?
it's
So
not same.
it is not same. So you cannot put it as X here. You have to put it as some different element Y here. Whereas for isotope, you can put both X here
Both of them.
because it is the
The
same.
same element.
Same,
This is also 17, this is also
same
17,
element,
isn't
but
it? This
different.
can be, this will be different. Neutrons change means no problem. We still call it as chlorine only. Okay. Whereas this fellows, because the atomic number is different, you can't say X. You have to call it one as X as well as Y. Okay. So that is about isobar. So as we just now discussed, calcium and argon, okay, both of these fellows have the same mass number 40, but we know that calcium atomic number is 20 and the atomic number of argon is 18. Okay, so these are two set of isobars. Likewise, nickel and iron also are isobars. Nickel and iron both are 58, but nickel is 27 atomic number, iron is 26. Are we good with this, guys?
Yes.
Okay, so that's about this topic called atomic structure. Okay, where we discussed various models and the important model of Rutherford's alpha ray scattering gold foil experiment we studied. We noted down the observations, inferences, and hence the actual model, its drawbacks, and how Niels Bohr proposed the fixed energy shells, quantum numbers, and overcame that. Okay, so Niels Bohr model also we should study, followed by 2n square electronic configuration rule, and followed by atomic number, atomic mass, isotopes, and isobars. That ends this topic. Okay, so in fact that also ends our chemistry syllabus.
Yes,
Right?
sir. There's no more chapter after it.
There is no
really
more.
less for CBSE.
That's okay. It gives us time. See, it. You will say this is so simple, no?
No,
The
important.
number of questions you can get out of this topic, humongous. It will
So
confuse
this
us.
FA they gave so hard questions, sir.
I know.
I will get really less, but I got 7 somehow, sir.
Yes. That's the reason. See, that the topic is simple, but if you have to understand it and answer all type variety of questions, it will be tough. That's why CBSE we have to practice a lot more. Okay, ICSE portion will be more, but questions mostly they will give
Okay.
simple medium. They will not give all hard questions. Okay, but because the syllabus is less, don't think the question also will be simple. In CBSE, you have to apply your brains.
So
Okay,
it was really twisted, sir. I didn't have a clue about how much we'll get, sir.
where, which one?
So chemistry, sir.
That you would not have studied, bro. In your case, there are exceptions.
So I
I
studied.
say paper घुमाएगा तो क्या होगा? You don't even memorize 20 atomic number past 3 weeks, 4 weeks, 1 month. I'm telling. I
Sir, I
told you
did,
that.
sir.
Now you know.
So I can tell.
That's okay. After so much of follow-up, you're telling that. So you have to study. Because now 9th onwards, no, 9th, 10th, you have to be very, very professional. You have to manage your time. You have to plan your work. You have to put so many hours. Okay. You have to become very serious. You have to take notes properly. So I will just share with you what I mean by good notes. Okay.